Hi everyone. So for our second example problem here, a practice problem, we have a cylindrical can that is partially filled with water. So it says that the radius of the can is 8 inches, and it says the height of the can is 9 inches. This is actually not information that we need. It doesn't really matter that the height of the can is 9 inches. But it does say that if the volume of the water is decreasing, so notice that the volume is decreasing at a rate of 527 cubic inches per minute, what is the rate? So what is the rate at which the height of the water is changing when the height is 5 inches? So we know that we have this radius of 8. It doesn't matter that the height was 9. We know that the change in the volume over time is decreasing by 527, and we want to find dH dt when h equals 5 inches, and that's the height of the water is 5 inches. And it actually doesn't matter that the height of the water is 5 inches either. This is not a value that we need in this problem. And it's because this volume of water is decreasing at a constant rate. So looking at the volume of a cylinder, we have the volume of a cylinder is the area of a circle times height. The radius of this volume of water is always going to be 8. So this volume can be rewritten as pi times 8 squared times h, or 64 pi h. And now we can take the derivative of both sides with respect to time, and we will have dv dt. This 64 pi is a constant that can come out in front, times dH dt. We know what dV dt is, so I'm going to bring this up over here. We know that dV dt is negative 527, and that should be a 64. And we're looking for dH dt. So if we divide both sides by the 64 pi, we will have our dH dt. And I think you can leave it like this and just say that dH dt is negative 527 over 64 pi inches per minute.